All right, and trig lesson chapter 3, section 2, applications of the radian measure today. We're going to talk about the arc length on a circle and the area of a sector of a circle. The arc length is referring to the length around the circle from this radii to that radii. If we go all the way around, remember that's called a circumference, but we're only going to do part of it, so it's called an arc length. The formula is given by you take the radius times the radian measure for this angle. Also, if we go back to geometry, you should have seen something similar to this, that we would say this is in degrees out of 360 degrees. See, that's the fraction of the circumference 2 pi r that I want. But remember, 2 pi was equivalent to 360 degrees if we converted this to radians. And that's where the rule, see the 2 pi, the 360 degrees, would be equivalent. Therefore, you would have your theta times r, and that's where that formula comes from. All right, the area of this piece of pie right here would be given as 1/2 the radius squared times theta. Again, if that theta is measured in radians. Also, you could think of it as a fraction of the area of the circle. So again, the fraction being in degrees out of the entire circle times the area of the circle is pi r squared. And again, the pi is equivalent to 180 degrees, so I could think of that 360 as 2 times 180. See, that's where this 1/2 is coming from. Then that would be in a radian measure. Okay, that's where the theta is, and then there's your radius squared. And so that's why I like to explain to you where those formulas come from. All right, so if we have a circle with a radius of 25 and 60 hundredths of a centimeter, find the length of the arc intercepted by the central angle having each of the following measures. So if we remember the formula for the theta, that would just be the radius times the theta as long as theta is in radian measure. So again, you just take your radius times the radian measure, that's your arc length. So it's really actually a very simple formula, you just got to memorize it though. All right, if I've been looking for, and the angle was 54 degrees instead, I could convert the 54 degrees to radians and then use this same formula. I also could think of it as I want a fraction of the area of the circle. See, all the way around the circle is 360 degrees. I only want 54 degrees of that circumference. So that would be 54 out of 360, and then I would take it times 2 pi r. Now, they went ahead and converted it to radians first, and then they took the radius times that radian measure, and therefore that's how they got their arc length for this problem. And again, like I said, I would have done is I would have taken the degrees. This I would have done here is 54 degrees divided by 360 degrees. That's a fraction of the circumference 2 pi r, where the radius was 25.6. So whichever formula you prefer, it doesn't matter to me which one you use. All right, Erie, Pennsylvania is approximately due north of Columbia, South Carolina. The latitude of Erie is 42 degrees north, while that of Columbia is 34 degrees north. Find the north-south distance between the two cities. So you got to think about you have a globe. Okay, so they also tell you the radius of the Earth. You do not have to memorize that. So what happens here is if you think about this for a second, you have your globe, you have your equator line, and you're going up, okay, you're going up 42 degrees to Erie, and you're only going up 34 degrees to Columbia. Okay, so again, you have your circle. Okay, it's representing the globe of the Earth from the equator line. So let me kind of draw a picture here, and then I will show you guys. All right, so what we're trying to show you is that this is the equator right here. Going from the equator to the smaller one right there, that would be going to Columbia of 34 degrees, and going up to the higher one would be going to, I'm sorry, the higher one was Columbia, and the lower one was Erie. And so what we have here is the angle between these two cities right here, the angle is at 8 degrees. Okay, that angle is 8 degrees. Now we want the distance between these two cities. We want this distance right here. Well, that would be an arc length. That would be a fraction of the circumference around the circle. Now, like I said, they like to convert things to radians and just use theta times r. So you convert your 8 degrees to radians. Remember, you multiply by pi over 180. So there's the angle measure in radians. And then we take that and times the radius of 6,400, and that's the length of the distance between the two cities, because that's the arc length. Now, I would have just done 8 degrees over 360 degrees. 8 degrees over 360 degrees times the circumference of 2 pi r. And mainly I would have used that formula just because my measurement was in degrees to start with. So I just go ahead and just go straight for that. It's a fraction of the circumference. I need to make you a side note because I believe one of the homework problems one year had asked if one city was in 42 degrees north and if the other was 34 south. If that had been the case, then the angle between the two cities then would be 76 degrees instead of this 8 degrees. Because if you have one of them going north of the equator, 42 degrees, one of them going south of the equator, 34 degrees, see the angle between them would have then been the 72 degrees. Actually, 76 degrees, sorry, if you add those together. All right, so this time we're given an arc length and we are asked to find the area. So I'm given the arc length. So these are the two formulas that we know. We know that the arc length equals the radius times the angle in radians. We know the area is 1/2 of the radius squared times the angle in radians. We don't know the angle in radians. I do know the arc length of S, and I do know the radius of 7. Now I want to find the area. So I know the radius there is 7. But see, I need that angle measure to get the full area. So I could get this angle measure right here by taking S divided by R. So the angle measure is 10/7 of a radian. So I plug my 10/7 back into over here, and then I can get my area for that sector. All right, this is another city problem. The two cities are 200 kilometers apart. They told me the distance between the cities. They lie on the same north-south line. The latitude of the northernmost city is 5 degrees north. What's the latitude of the other? The radius of the Earth is approximately 6,400. So here's what we have. We have got the distance between the two cities is about 2,000 kilometers there. We know the angle from the equator all the way up to the higher one is 50 degrees north because that was the northernmost one. So we do not know the latitude of this city, that means from the equator to the bottom one right here. So what I do know, though, is that the arc length, that's the 200 kilometers, equals the radius times that angle measure. Divide by the 6,400, and that's my answer in radians for the angle measure. But I need this in degrees, because when we're talking about like 50 degrees north, and we're talking about all these latitudes, that's in degrees, it's not in radians. So this right now at this point is in radians, so I need to convert that to a degree measure. So to convert it to degrees, remember we times by 180 over pi, and that would give me my answer in degrees so far. Now my final answer is not 18. That's the measurement between these two cities is 18 degrees right here. Remember, to the northernmost one all the way up to the top was 50. The distance or the angle between them is 18. So therefore, what I really need to say my final answer is 32 degrees north. Okay, the southernmost city is 32 degrees north of the equator, basically. A rope is being wound around a drum with a radius of 327 thousandths meters. How much rope will be wound around the drum if the drum is rotated through an angle of 132 and 6/10 of a degree? So basically, we're looking for the length of this arc right here on this brown, because that's the angle measure that it's went. Now, see, that's in degrees. So personally, I would have done 132.6 over 360 times 2 times pi times r. That would give me the length of that rope. Now, the problem here on the slide is probably going to convert it to a radian and then just use the radian times the radius. So they did. They took this answer to convert it to radians. It's times pi over 180. Then you take the radius times that radian measure, and that's the distance that the rope has been wound. And again, like I said, I would have taken the degree measure out of 360, then times 2 pi r. So both get you to the same answer in the end. All right, two gears are adjusted so the smaller gear drives the smaller one. The radii of the gears are 3 and 6/10 of an inch and 5 and 4/10 of an inch. The smaller gear rotates through 150 degrees. Through how many degrees will the larger one rotate? If you end up studying anything in type of mechanics and any type of work being done where you're having to use gears to make something be stronger or gears to make like a car go faster, this is where the application would be applied. All right, so we're talking about the arc length. So as the smaller one travels, whatever this arc length is it's traveled. The larger one had to travel the same arc length. For that to happen, as this little gear starts turning, it's going to turn faster while the bigger gear would be turning slower in terms of revolutions per minute anyways. So when we're looking at it here, we know that the small one went 150 degrees out of the 360 degrees times 2 pi r. The large one, we want to know how many degrees does it rotate through out of the 360. Remember, this is going to be a fraction of the circumference. That's the arc length for the little one. This is the arc length for the big one. There's the fraction times its circumference as well. Notice on both of the problems, the 360s would be gone if I multiply both sides by 360 degrees. Finished. 2 pi, I can reduce that off of both sides as well. So I end up here with 150 times 3.6 equals n times 5.4. So I multiply these two, divide by 5.4, and the larger gear would rotate through 100 degrees then. So it tells me to find the area of the sector of the circle with a radius of 15 and 2/10 and a central angle of 108 degrees. So I could do the fraction of the area of the circle, so 108 out of 360 degrees times pi r squared. They're probably going to convert it to radians again, because the formula with radians is 1/2 the radius squared times theta. Again, the theta there is measured in radians. So I already know the half, but I needed this in radians. Now remember, that was in degrees, 108 degrees, so that would be times pi over 180, where those degrees would then cancel. Okay. Now I'm not saying 108 and 180 cancel, I'm saying the degree symbols would go away. That's the conversion to radians. And like I said, this is what I would have used. I would have used the fraction of the area of the circle. If my angle measure is given to me in radians, I use the radian formula. If it's given to me in degrees, I just use the degree formula. All right, this one in your homework is number, well, at least it was 11 last year. I'm not sure if it's 11 for you guys still. The figure shows the chain drive of a bicycle. How far will the bicycle move if the pedals are rotated through 180 degrees? Assume the radius of the bicycle wheel is 12.3 inches. A bicycle chain drive has a small gear with a radius of 1.25 inches and a large gear with 4.25 inches. I felt the picture. I had a little bit of trouble the first time I was helping somebody with it because I wasn't quite understanding my picture. You understand, right here on the right, this is the actual pedal, like what you step on. So as the pedal's going around, okay, the radius of this big sprocket is 4.25 inches. Okay, the chain is then hooked to this little one on your tire. Now on this little one, it has a little radius of 1.25 inches, and that's the gear which is attached to the wheel. Okay, remember there's a wheel attached to that one right there. Alrighty, so here we go. We're going to start off with the arc length is the radius times the theta. So the larger gear moves. Okay, so this is the larger gear because the pedal is what's moving 180 degrees. This is the large one. So it's moved 4.25 times pi, because 180 degrees is the same thing as pi radians. So it's moved a total distance of 13 point, all these decimals, inches. That's the distance that this chain has moved when that large pedal moves 180 degrees. Now we need to figure out for the small one. Now remember, the small gear has to move that same distance because that's the chain that's moving. So there's the distance the small gear has traveled in 1.25 times the angle in radians as well. So we're going to figure out what this angle is because we need to know what the rotation has been on this little one right here. So I divide by the 1.25. So the radian measure for this little one is 10.681450. That's the radian measure that this one has traveled through. Now it asks me the tire. How far has the tire gone? See, you got to remember the tire is attached to this. Okay, the tire is attached to that right there. So we were told, right, back in here in a minute, the bicycle wheel had a radius of 12.3. So there's its radius, and there's the radian measures it's traveling through. So there's the R and the theta for the tire. So the theta for the small gear equals the theta for the tire because these two are hooked together and both rotating at the same radian measure. All right, I hope that explanation on this helped you out for number 11 on your homework. All right, so you might want to go ahead and try numbers 4, 7, 11, and 17 first before you do the rest of the assignment. Again, these two is if your measurement is given in radians, and these two I use if my measurement is given in degrees. That ends 3.2.